This slide is explaining the post-assessment, which is due to this week on Friday. You have the assessment already available on School City, and you have a preview, as I've shown you, on this link here. This is the link for the class link, and then you open School City, and you can have a preview on PDF right here. My suggestion, work your answers on paper and pencil on a PDF, and then after that you open School City and input your answers. You're going to have the whole week to do it. You can work every day a little bit, and on Friday you input all your answers on School City. I'm going to give you the whole day. We don't have meeting on Friday. I will be available if you have any technical difficulties on School City, and I will help you out specifically in inputting your answers on School City. Okay? If you get a grade greater or equal than 75% on this post-assessment, I will give you 100% on all the assessments, not all the assessments, all the tests that we have on this fourth quarter. We had a test already on April 13. We can have this test on April 30, and there's another one on May 21st. So you will have 100% on all the tests, because this post-assessment includes the whole course, covered all the topics we learned during the course. That's my proposition. I think that's a good motivation so you can work and do well on this post-assessment. If you get a grade that's less than 75%, not a problem. You're still going to have a good grade here. If you finish before the due date, I still will give you an extra credit, and you will still have May 21st tests to improve your grade. Okay? So, but it's a good motivation. It's a good I think incentive to work hard on this post-assessment and have an excellent grade at the end of the fourth quarter. Any questions about post-assessment? Any questions? No questions? If you have no questions, let's move, because we have a quick review on the work we have done on Friday. This is the example we worked last Friday. See how to solve exponential equations, and we solved this one. 4 exponent 2x minus 9 equals 64. Remember this? And the solution is, check this step by step. The first thing you have to do is to find a common base, to have both sides of the equation with the same base. And if we have on the left hand side the base 4 exponent 2x minus 9, maybe it's a good idea to change the right hand side to have the same base 4 as well. And that's okay, because 64 is 4 cubed. We can change 64 by 4 cubed. Then we have base 4 on both sides of the equation. Now we can compare the exponents. See? 2x minus 9 with 3. We can say, yes, the exponent 2x minus 9 needs to be equals to 3. After that, it's just addition property of equality. Move this negative 9 to the other side, becomes a positive 9. And then 3 plus 9, 12. And now we have to apply multiplication property of equality to find the answer. But wait a minute, the answer is missing. We don't have the answer. There is a question mark instead. Can you help me find the right answer? I will invite a couple of students to help. I think 6 looks promising. 6 looks promising. Let's try Kimani. And we can check here 2x equals 12. Divide both sides by 2. You're going to have x equals 6. Nice. It's a good sign. means 6 is a good guess, a good number. Let's plug in. 4, 2 times 6 minus 9 equals 64. Let's check if this is true. 2 times 6, 12. 12 minus 9, 3 equals 64. Yes, 64 equals 64. Yes. Nice. That's the right answer. 6 is the right answer. 6 is the right answer. Thank you. Thank you, Adriana. Thank you, Kimani. And the right answer is 6. We check it and recheck it, and yes, x equals 6 is the right answer. All right, thank you. And I think we know, at least we know the step by step, how to solve exponential equations. Now let's move on. We finished chapter 8. And now we don't need this. We will have a quick review of chapter 8. Let's go to the beginning of chapter 8, section 8.1. We worked on functions and algebra of functions and composing functions. Remember this? We're going to review this today. If we have, let's say, two functions, f and g, we can, you can apply algebra, you can add, you can subtract, you can multiply and divide the functions. Just regular, simple operations. Let's work on an example, okay? Let's say we have here g, g and h. G and h, okay? And we want to find g plus h for x equals 3. A simple addition. We will add function g, 5x plus 1, function h, x cubed. So this is function g, this is function h, and we will plug in x equals 3. So instead of x, we're going to plug in x equals 3 on both functions. This is equals 5 times x equals 3 plus 1 plus x equals 3 cubed. 5 times 3, 15, plus 1, 16, and 3 cubed, 27. The right answer is 16 plus 27, 43 is the right answer. Questions about it? So if we have regular operation, addition, subtraction, multiplication, division, we just will work like this. And if necessary, we're going to plug in the same number, the same x into both equations. Okay? Now, any questions about this one? This, I think, is something we know how to work with regular operations. But we have a new one, the other one, the composition, that is completely different, okay? This is how we work. Again, addition, subtraction, multiplication, and division. Now, the other operation is to compose. Composition of functions. And this is a new thing. It's completely different. Let me show you. And the symbol is this little empty dot. It looks like an O, a tiny O, but it's actually an empty dot. And you're gonna say F compose G. Okay? f compose g of x equals f of g of x. Okay? Now let's find out. Let's say f equals 4x plus 3 and g equals 7 times x. Now, first you're going to write down here f, 4x plus 3, right? This is f. But we don't want f, we want f of g. We want f of g. We're going to substitute x by g. So erase x, and you're going to, in this place, you're going to write down g. 4 times g plus 3. But g is 7x. So we can write this is equals 4 times 7x plus 3. Make sense? And this is equals 4 times 7, 28, x plus 3. Now tell me, make sense? Does it make sense? Do you have questions? You can see it's a bit confusing, it's different. You just have to keep in your mind that composition is a different kind of operation. It's not like the other ones. It's not like addition, multiplication, division, subtraction. No, composition is a new thing, it's different. You will plug in one function into the other one. It's a bit confusing, but keep in mind that you need to follow a different step by step compared to the other ones. Okay? And if you have questions, send me now. If you have any comments, any feedback at all, any step that you're still confused, or anything at all that's in your mind, send using the chat box, or you can say using the microphone. Let's find the right answer, and we have at least one winner. Yes. Today we don't have so many students joining the meeting. I think we have 7 or 8, but we have a winner. We have a winner. I will suggest. I suggested y equals x plus 2, right? And I've tried x plus 2. It didn't work. Well, it worked with the first one. 1 plus 2 is 3, but it didn't work with the next. 2 plus 2, 4. No, 3 plus 2, 5. So it's not x plus 2. Definitely not x plus 2. One thing we suggested you to try is 2x. 2 times x. Because it's not going to be the right one, but we'll get very closer. Check this out. 2x, then you have 2 times 1, 2. 2 times 2, 4. 2 times 3, 6. 2 times 4, 8. 2 times 5, 10. Right? Thank you, Jorge. But then there's a difference between this output that we calculated with 2 times x with the output from the table. Just one difference is a constant difference, right? Only one less is missing 1 unit. Maybe if we add 2x plus 1, we will find the right answer. So let's check. Maybe 2x plus 1. 2 times 1, 2 plus 1, 3. 2 times 2, 4 plus 1, 5. 2 times 3, 6 plus 1, 7. 2 times 4, 8 plus 1, 9. 2 times 5, 10 plus 1, 11. Yes. So the right answer is 2x plus 1. Y equals 2x plus 1. This is the correct answer. And we have a winner. Yes, Dayanara. Excellent. 2x plus 1 is the correct answer. Thank you, Dayanara. Thank you, Jorge, Timothy, Kimani, Leonardo, and Joelian. And Dayanara got the right answer. 2x plus 1. This is just to illustrate how function works. It resembles this function machine. There's a machine that will change the inputs into the outputs. And if you talk about a math function, the inputs will be x, the outputs will be y. And the function is a math rule, a math equation that will change the input into the outputs. All right, thank you. Now let's move on. Let's move on to the practice, to the quiz. And today is a review from section 8.1. Let me show letter A, how we're going to work on letter A. We have the functions here on top, and on letter A is a simple subtraction. We have to subtract function f from function g. Let me write down here, subtraction. And function f is what? X minus 4, right? This is function f. Function g is, we have here on top 2x squared minus 8x, right? Let me just write so we can remember. This is f, this is g. Okay? That's it. X minus 4 minus 2x squared, and negative with negative, positive, plus 8x. That's it. We just need to now we just need to simplify just have to simplify and combine like terms, because we have some like terms, x and 8x, that we can combine, and we have to write in the correct order. First, the highest exponent, negative 2x squared. The next highest exponent is 8x plus x, 9x. And the last one is the constant, minus 4. And this is the right answer. Okay, and we are looking here at a simple operation, addition. Now let's go at to the end of this part of the quiz, where we have the new kind of operation, the composition. And again, composition is different, it's a new thing. We will have f compose g of x, it's going to be f of g. We will plug in g into the function f. But the function f is x minus 4, right? This is the function f. We don't want the function f. We want the function f of g. So instead of x, we're going to plug in here g. G minus 4, okay? And g is equals to 2x squared minus 8x. This is g. Minus 4. Now we have the result. This is the composite function, f of g of x. Now, give me 1 minute. I will check attendance, make sure that everybody is marked present, and after that we can work on more questions together. Okay?